Let's solve another related rate problem. So two cars leave an intersection at the same time. One headed west and one headed north. Together, those two cars create a right triangle. All right, so the westbound car is moving at 40 miles per hour, and the northbound car is moving 50 miles per hour. 15 minutes later, what is the rate of change in the perimeter of the right triangle created using the two cars in the intersection? So let's identify all our variables. So we could call this one A, and this one B, and this one C. So A is the westbound car, and B is the northbound car, and C is the distance between them, or the hypotenuse of the right triangle. And P is the perimeter, because we are dealing with the perimeter of the right triangle created using the two cars in the intersection. Identify which, if any, of the variables in the problem remain constant. All right, so as A and B change, so is C, and so is the perimeter. So none of these were going to remain constant. Identify the rates you're given and the rate you wish to find. So we are given dA dt, that is the speed of the westbound car, so that is 40 miles per hour. We are given dB dt, that is the speed of the northbound car. Oops, not 15, 50. We need to find out dP dt. Right, that's our unknown that we're looking for. All right, so write an equation to relate those variables. So we're going to be using the perimeter formula. So that is P equals A plus B plus C. Now we have a little bit of a problem. We know when we take the derivative, we've got dA dt, we've got dB dt, we don't have dC dt. So we're going to have to do something to rewrite C in terms of the other variables. Now remember, this is a right triangle. So we could, so A squared plus B squared equals C squared. We could represent, actually let me put the C squared by itself, since that's the one that's going to be replaced. So C squared equals A squared plus B squared. So we could replace C with the square root of A plus B. Does need to stay a variable because it's changing. It's not remaining constant. All right, so now let's try that. So we have P equals A plus B plus, and I'm going to rewrite that as A plus B to the 1/2 power. All right, so now we have an equation that A squared and B squared. So now we have an equation that we can take the derivative of. All right, so let's take the derivative and then we can see if we need anything else. All right, so derivative of P is going to be dP dt. Oops. Derivative of A is dA dt. Derivative of B is dB dt. Because these are all being taken with respect to time. The derivative of A squared plus B squared to the 1/2 power is going to be 1/2 times A squared plus B squared to the negative 1/2 power times the derivative of the inside, d dt, since it's with respect to time, A squared plus B squared. So this is a little bit trickier in terms of the the derivative. All right, so dp dt equals dA dt plus dB dt plus, and we have 1 over the square root of a squared plus b squared. And then the derivative of a squared plus b squared is going to be 2a dA dt and 2b dB dt. All right. Now we've got our, so not too bad, we got our dP dt isolated. But now we need to plug in, and let's think about what all the values are. We've got dA dt and dB dt up there, so that's no problem. But what about A and B? What do we plug in for A and B? Well, the cars are traveling for 15 minutes, which is 1/4 of an hour. So if the westbound car is only driving for 1/4 of an hour, and he goes 40 miles an hour, he's going to go 10 miles, right, in 15 minutes. And if B is going 50 miles an hour, he's going to go 12.5 miles in 15 minutes. So now we've got the A and the B that we need. So now it's just a matter of plug and chug. So this was 4, and this was 5. We've taken the derivative. And so now 6, let's clean this up. Plug in and simplify. So we have dP dt equals dA dt was 40. dB dt was 50 plus 1 over, I'm probably going to want a calculator, 2 square roots of 40 squared plus 50 squared. Couldn't give us Pythagorean triples. Times 2, and actually this should be in parentheses. So times, let's put that all in parentheses there. All right, so then times 2 times 10 times 40 plus of course that I needed more space. You know what? Let's just put this in the top and in the numerator, and I won't need quite so much space. All right, so 40 plus 50 plus, all right, so in the numerator, let's put 2 times 40 times, oh, excuse me, A is not 40. A is only 10. Times 40 plus 2 times 12.5 times 50. All right, that's a lot of plugging and chugging. We're not gonna explain it. We'll explain it verbally. We won't write it down because we're gonna use up all our space. dP dt equals, all right, so this is 90 plus, so in the numerator we've got that's a 2 and a 10, 20, we're at 800 plus 50 times 50, that's going to be 625. Wait, 5 times 5, no. Thinking 5 to the 4th. 50 times 50 is 2,500. So that's just 2 times 25 is, and that is no, that's a 12.5. Excuse me, I can't read my handwriting. 2 times 12.5 is 25. 25 times 50, right, so 25 times 5 would be 125. Pluck a 0 on there, and that would be 1250. All over 2 times 1600 plus 2,500. Not a perfect square. We'll get a decimal equivalent. So dp dt equals 90 plus calculator time. All right, so in the numerator, we've got 2025. In the denominator, 2 times the square root of 4,100. I hope you can read that. And our final answer is I have to be able to read it. All right, so 2, I'm trying to hold this and a microphone at the same time. Square root, and it's kind of dim, 4,100. All right, so then I've got that value divided by, and then plus 90. All right, so it is 105.8126 miles per hour. There we go. So now we have calculated out the rate of change in the perimeter. And so that means that when, after 15 minutes, the rate of change in the perimeter is 105.8126 miles per hour. And I could have wrote MPH. And we are done. Thanks for watching. Bye for now.